Okay, I'm Kelly Ochuko Egode of Omfeonix Agritech Ltd. The work I'm going to present is part of our project for climate change and renewable energy. So I work along with Dr. Aliyu Ibrahim Daba, Dr. Hassan Said Mohammed, and Victor Oladeji. So our topic is autonomous climate resilient farming, how AI, IoT, and renewable energy integration enable net zero aquaponics at scale. So today we know that climate change has a lot of effect on almost everything we do today. And this also have strong impact on agriculture, which is a major contributor to climate change. From erratic weather, and this results to erratic weather conditions, and the use of different fertilizers also contribute to high carbon footprint. Then the emissions from transportation also have a high effect, releasing greenhouse gases. Then also deforestation also lead to climate change. All of these affecting the current way we practice agriculture. Now, our focus is to have a situation whereby we have a sustainable farming where the impact of net zero of climate change is close to zero. So how do we achieve this? We want to achieve this by having different technology integration like the AI, Internet of Things implementation. Then also being able to manage the environmental impact, like reducing the carbon footprint and waste management. By doing this, we want to reduce the net zero, and that is where the renewable energy comes in, and also using the waste from the agriculture to produce the biogas, thereby reducing high dependence on fossil fuel that comes from the normal grid system. So, and by doing sustainable farming, we are able to manage our nutrients effectively, manage water resources, and other form of activities that we do within the aquaponics system. And this, at the end of the day, gives us a climate resilient way of farming and high yield, thereby ensuring that we have food security. Now, what is aquaponics? Aquaponics is a closed system where we have aquaculture and hydroponics coming together in a symbiotic way in the same ecosystem, providing food, and is a sustainable way of farming compared to the traditional way, and this is the way to go. Then what are the advantages of exploring the aquaponics system? We have reduced water consumption compared to irrigation system that you use in traditional field agriculture. Now, it also reduces the use of chemicals. We don't need pesticide. We don't need to do a lot of fertilizer activities that causes more havoc to the land, because now you have to do regeneration of the land and the likes. You don't need to do all of that. Then also you have increased productivity because you grow year all round. You grow from season to season. You're able to grow your crops, thereby having increased productivity. Then also we have reduced environmental impact because we apply sustainable practices. We are not using fertilizers. We try to minimize the use of just only grid system of source of power. We're able to minimize our carbon footprint because we now explore options of renewable energy like the solar, wind, thermal, and the likes. Then because of this aquaponics way of farming, we are able to localize our food production, thereby those local food that you want to eat, you're able to produce them locally, thereby reducing the cost of transportation and the cost of producing food. Then, what is the role of artificial intelligence, Internet of Things in aquaponics circle, which is the cruise of what Omfeonix Agritech is working on. Now, with aIIot in the aquaponics circle, you are able to monitor end-to-end the entire aquaponics farming operation using different sensors from pH sensor, dissolved oxygen sensor, your CO2 sensor, electrical conductivity sensor, and the likes, ammonium nitrate sensor. You are able to monitor, then even monitoring the power that comes in from either the grid or renewable energy. You're able to have an end-to-end management of the entire system. You also use camera sensors to manage how your fishes are how the crops are growing. Likewise, your fish behavior. So aIIot gives this visibility to your farm's operation. Then with big data, one is able to analyze all of these processes in real time, thereby getting insights to the operations of the farm. Then with remote management, with optimizing the system, because I have data, I'm able to get insight. I will be able to do what? Optimize the system, thereby increasing my yield by understanding where there are challenges and acting real time to resolve those issues. Then I can also automate my task by using robots or using or thereby minimizing labor or manual activities with the help of aIIot. This will ensure that wherever I am in the world, I have visibility to my farm operation. I can remotely take decisions that require my input. So this is what aIIot does to the aquaponics system. Now, the future of aquaponic farming ensures that we have real-time monitoring and control. We're able to make predictions. We're making forecasts into the future, what is obtainable within my farm operations based on my historical data. And I'm able to automate different tasks like feeding habits. I'm able to automate changing, dosing the system, with dosing the plant, the hydroponic part of the system with nutrients if that is required. Then I'm able to optimize the operations. But like, for example, my pumps, I'm able to optimize their usage effectively. And also, I'm able to optimize the use of renewable energy instead of relying strictly on the grid system, thereby reducing my costs, right? So all of this I'm able to do remotely. So this is the advantage, and this is the future of aquaponic farming, and that is what Omfeonix Agritech is working on. Now, renewable energy integration for net zero operation. Now, we all know that the grid system rely mostly on fossil fuel, and this results to high carbon footprint within the ecosystem. So with the integration of solar power, we're able to reduce carbon footprint. Then wind, which is also a renewable source of energy, we're able to reduce carbon footprint. Biogas, which is source of waste from the aquaponic system, waste from the fish excreta, waste from the fish feed, waste from the plant growth, and other decomposable organic materials. They all form source of material to biogas system to produce energy, which is being used within the aquaponic system. Now, thermal energy is also an area of exploration that will help achieve net zero operation. So, challenges in scaling aquaponic system. One of the major challenges is that there's high investment cost. Technical expertise is very low. We have very few expertise in the field of aquaponics. Now, combining that with aIIot, that also shrink the expertise that is required to give that scalability when it comes to aquaponic system. Then data security, because we have so many modular systems. For example, the sump system, the biofilter system. There are a lot of data that comes from that angle. The water quality management system, there's a lot of data that comes from that angle. The hydroponic system, a lot of data comes from there as well. So data security is a major challenge, and that requires a high level of expertise to be able to ensure that the entire system of the aquaponics operation is fully managed. Then scalability is also a big challenge, because aquaponics system is such a complex system. Scaling is quite difficult, but with the help of Omfeonix Agritech, all of this is achievable. Now, aquaponics system challenge, like I mentioned earlier, are scalability, data security, and technical expertise. This is what Omfeonix Agritech is resolving as far as aquaponics system is concerned. Now, we are focusing on an aquaponics farm in Bristol in UK, where we did some work. So this is a typical aquaponics system with renewable energy being inculcated. Now, we worked on, we installed our device, Aqua Echo, to manage this aquaponics farm and have visibility to the different operations. And this shows some of the data we're able to acquire from that farm based on the different integration of renewable energy and its grid system operation. So we have we manage, monitor the fish weights, the plant biomass, and different harvest activity. They will also monitor the gather data on the environmental factors like temperature, humidity, and wind. Then the integration of power management, solar power, wind, biogas, and the grid system. So also different systems like the actuators, like power pump, heater, then the sensor health, then the cooling, other cooling system, and aeration. So these are the different data we're able to gather at different time of the year, whether daylight or when there's no daylight. The different hour, we're able to gather different data. Then this is data distribution by hour, by daylight, and distribution over within the year. But this is between January to early August. So this is data distribution. So from these, we're able to make predictions on the temperature, because temperature has a lot to do within the system, because we're in a temperate region. So temperature, the weather, has a lot of role to play within the aquaponics system. Then in trying to build our AI model, we worked on the different metrics, metrics to make our predictions. So some of the features we worked on are ambient temperature, then the water temperature, wind speed, battery source that gathers the source of power from the renewable energy. So we're able to store those power within the battery storage system. Then humidity and solar radiance. We can see that the ambient temperature has a lot of importance in making our predictions. Then, looking at our results, we realize that the system relies so much on renewable energy because of the temperate region we operate. And we're able to manage the nutrient recycling system effectively, about 85%. Then freshwater savings, because of aquaponics system uses less water, we're able to use just 10% by topping it up, and that, as a result, we're able to save close to about 90% of normal operative water usage. The water recirculation was quite effective. So these are, and all of these help to preserve our environment. Take, for example, a typical RAS system, aquaculture system, where you have to evacuate water. and that causes environmental hazard. All of that were minimized or almost overcome by implementing these aquaponics system. Then this is a comprehensive performance dashboard between January to August 2025, showcasing the different impacts of the different metrics we monitored. Here we can see that in around January, we can see that the temperature is very, very low. Even with the heating, this was what we were able to achieve. And as a result of that, dissolved oxygen was a bit high. Now, as temperature increases, reliance of more supply of renewable energy increases, we were able to stabilize the environment more, and the system was able to gather enough energy, because the focus here is how we are able to acquire energy and move from grid usage to the use of renewable energy to enable us minimize cost and thereby reduce carbon footprint by not relying on the grid system. So as you can see, we're able to generate more energy as the weather condition temperature increases. We're able to stabilize the system. Then these are the different metrics against the target. For energy efficiency, we're able to establish a very good metric, like 100%, everything was okay. But when it comes to operational accuracy, we still have some gap, which will be source of improvement as we continue our work. Also, resource utilization, most probably from the pump system, wasn't that effective. These are some of the things we worked on. Initially, it was about 60%, but by the time we were doing this metric, we were able to improve to 88. We still have more to work on this. So now, when we talk about the ability of our aqua ecosystem to make predictions, these were the different metrics that we got, and we realized that we were able to have that energy autonomy where the system was able to effectively switch from using stored energy on the battery system instead of using the grid, and thereby reducing energy and thereby reducing carbon footprint utilization based on the farm's operation, because the system is able to automatically switch to using source of energy from the renewable energy by powering the pump, powering the aerator within the ecosystem, thereby reducing reliance on the grid system. Also, this shows the seasonal performance from winter to the period we are in now, and this was able to show that everything worked as expected. Then within winter and summer, we can see that the energy performance during winter, the generation was a bit low, but as we move forward, that performance increases. So also system efficiency comparison, we can see that renewable energy performance was far better in the summer, which is as expected. So what we now need to work on more is how we can increase our operation during winter. How do we get that done? So this is a part of the observations we have and things we need to improve on to make aqua eco more efficient as we move towards this winter period. Those are the things we work on to see that we're able to increase this metric from 49% to a higher percentage. So from all these indicators, we're able to achieve energy cost savings by 40%, and with the automations, the self-corrections, and being able to switch between reliance on grid to renewable energy, we were able to reduce manual labor by 70%, and the yield so far was about 30%. So we have been able to achieve this metric. So within this winter period, our target is to see how we can improve on these metrics as we continue our monitoring and review of our entire process, so that we can have more optimal results. Thank you.